Welcome back to part 2 of waves and how they are relating to sound. Here we're going to talk about some of the terms we use to describe the characteristics of a wave. We use the word frequency, we use the word wavelength, and we also use the word amplitude, but I'll have that written on the next page when we get to that. So frequency. Frequency is measured in hertz, Hz. So if you've seen something like, for me, I see them sometimes on a TV screen or a monitor. You may see something that says 60 Hz, or you may see this sort of terminology used from like power sockets, a certain frequency for the power grid. These are all measurements of how of the frequency of something. It's about how many cycles per second. In terms of a sound wave, we're talking about the undulations. How many times does it come back to its starting position in a single second? So for a high-pitched sound, we go to high frequency. So my little wave here, it's oscillating quite quickly. I've got a high frequency. With a low-pitched sound, the waves tend to be much longer and drawn out. So that's more of a low-frequency sound. You may see these sort of things, these little waves in recordings, where if I've got silence, the wave looks like this, and then somebody says something as a word, and it ends as like this sort of impulse. These are very similar to what we're looking at here. A high pitch has a high frequency. A low pitch sound has a low frequency. And we can define it by how many times it cycles across the length of 1 second. So let's say that this horizontal length here is one second of time, and I would count how many peaks I would have to consider what the hertz would be. And if this length here horizontally is 1 second, I could count how many peaks across to determine its frequency. Now we're going to talk about wavelength. Wavelength is a way of, it's related to frequency. You can use wavelength to determine the frequency number. Put simply, the wavelength is the distance between every hill to another hill, so from there to there, or it's the same thing as going from the middle to the middle, or from the trough to trough, as long as they're back to the starting position. So if I follow it from here, I would follow the wave until the wave starts to get back to its returning position, which will be here. If I consider the wave from the trough, I would start from here, follow it through, up the hill, back down again to its starting position, which was a trough. So that distance here is the wavelength. You may see a mathematical symbol to represent wavelength. It's this symbol here, lambda. Looks like a fallen over sort of tripod that go on that side. So you might have this equals, 60 something something to represent the wavelength sometimes, depending on what you're looking at, what kind of wave. The diagram here I've just got below, I've put these longitudinal waves also. So see where these particles are really bunched together for the compression, and that represents the hills. And these regions where there's very few particles in there, that represents the troughs. So I haven't aligned it perfectly, but I hope you can sort of make that connection. Next, we're going to talk about amplitude.